this leads naturally into the simple recognition of the great spiritual wisdom. There is only one mind, because mind separated into separate parcels of space and time makes no sense from the point of view of quantum physics. And the theory of entanglement is one of the indications of the truth of that statement.
Welcome, thoughtful viewers, to Science and Spirituality on Supreme Master Television. This program is part 2 of the 3-part series featuring an interview with a popular quantum physicist, author, and lecturer from the United States, Dr. Fred Alan Wolf. Dr. Wolf earned a Ph.D. in theoretical physics from the University of California, Los Angeles, USA, in 1963. He has lectured across the world, conducted extensive research in his field, written many award-winning books, such as Taking the Quantum Leap and The Spiritual Universe, and served as the resident physicist on the Discovery Channel program, The No Zone. Dr. Wolf has appeared in popular films, such as What the Bleep Do We Know and The Secret. He is known for explaining the complex laws of quantum physics in an engaging way so that non-scientists can better understand them and see how they relate to spiritual principles. His fascinating work has sparked the interest of many to deeply inquire into the very nature of existence and the mind. Last week, Dr. Wolf explained what led him to become interested in the relationship between quantum physics and spirituality. Today, he provides his perspective on fascinating subjects, ranging from the nature of reality to the quantum entanglement theory to how quantum computers could possibly develop their own consciousness in the future.
The good question is, what is reality? And what does it mean to talk about reality in any significant way? Clearly, there seems to be some boundaries between what we call what's real. You have your reality, I have my reality. That seems to be the case. However, when you begin to look deeply into this question of quantum physics and how mind enters into it, we cannot find a boundary from one mind to the next. We cannot find anything which distinguishes your mind from my mind. We have the experience of such a distinguishing going on. But if you really look at it, and I look at you, and I say to myself, that's a human being, but I don't have any experience of you other than what I'm experiencing from my natural senses. I'm not inside your head looking out your eyeballs. So I don't know what you're seeing. I don't know what you're smelling or tasting. I can imagine what those things are, but I don't have an experience of that. So that's a tendency to say, well, since we seem to have separate bodies, we must have separate minds. But according to what we understand about mind, it doesn't have any place where we can make the compartmentalization take place. In fact, Erwin Schrödinger, one of the founders of quantum physics, actually came up with a proof that there wasn't any separation between various minds, even though it appears that there are.
Mm-hmm. So that would bring us into the quantum entanglement theory. Could you explain that?
Well, in quantum entanglement, it can involve mind, of course, but what it involves is what happens after what is called an interaction. When things interact, we usually have a picture of an interaction as something coming together and flying apart. Bingo bango, bingo bango. That's an interaction. And the question then becomes, if I know what's going on before the interaction, can I say what's going on after the interaction? Now, if these were billiard balls, classical snooker, or some game like that, and we'll hit a ball and bounces at another ball, and we know what's going to, the snooker players, the billiard ball players, know how to control that. So they can say, given that I push the white ball with a certain amount of momentum and hit a certain space, it's going to hit the red ball and it's going to fly off in a certain, and everything is correlated. Correlated, same word. In other words, I can have control of the initial conditions, which are the ball I'm trying to hit, which is at rest on the green maze table, and the little white ball I'm hitting with my cue. I have control over the position and the momenta of both objects, so I can predict what the position and momenta of the two objects are after they hit and fly apart. Momenta being mass times velocity, or the movement of the object as it goes flying off in a given direction. That's called momentum. Anyway, that's fine. But in quantum physics, we have no such control. We don't know exactly the position and momenta of each object to begin with. But once they interact, they become what is called entangled. They become in a correlation, which means since we don't know exactly where they are, the question arises, what do we know about these objects? And the question then is answered with this answer. We do know that if you measure the position of the object on the left after the interaction, you can predict the position of the object on the right after the interaction. But if you decide to measure the momentum of the object on the left after the interaction, you can predict the momentum of the object on the left after the interaction. But you cannot predict both the position and the momenta of either object after the interaction. You can't, even if you measure both at the same time, you cannot determine what the other object is going to have. Entanglement tells us that they are correlated, provided you ask one question but not both. It's a kind of a funny kind of 20 questions thing where you can't ask all the questions at once, and you can't determine the answers to all of them.
So there seems to be a buzz going around about quantum computing.
Yes.
What's going on in this field?
Well, let me explain as basically as I can about the difference between a quantum computation and a normal computation. Computers are very simple, basic tools that are very complicated because the very basic tool is multiplied by a zillion times. The basic tool is simply up or down, on or off, 0 or 1, 0 or 1. That's the tool. In other words, it's a switch.
All right.
All a computer is a bunch of switches. You can think of a switch as something which you can throw as going so down, up, or side, up, down, up, down. That's it. Two switches, two switch positions, and that is an ordinary computer. A whole bunch of these things, billions of them. And that's how it works. Basically, change the positions of the switches, there's two possible positions here, there's another one over here, two more, that's four possible positions. They can be both up, they can be both this way, they can be like this, or they can be like this, so there's four now put three of them in, that leaves 2 times 3, it's 8, and so forth. So 2 to the power of how many different switches there are is the power of the computer. It can be very large. 2 to the power 10 is already more than 1,000. So you can see that you can get a lot of different possibilities. So now we come to a quantum computer. It's also made of switches, but all of these positions in between are allowed and can be computed in combinations with the other ones. So there's an infinite variety in each switch of possible positions. So you have as many as different possible positions this has, multiply that by as many as switches there are, and you have a quantum computer. Of course, because they're so flimsy in a way, they're not very robust, you have to really isolate them to make sure that you don't make them snap. Now, the thing which makes quantum computation of interest is that even though there are all these different positions possible, when you make computations, when you don't actually observe what's going on, very important, you don't look. When you actually observe any one of these switches, what you're going to instantly get is or that, but never anything in between. So here you have a situation in which...
Is that because of the observer effect?
That's exactly it.
Okay.
So what a quantum computer does, it has a way of observing or bringing in the observer, and the question is whether the machine can observe its own state or not is still an open question. I will lend a little bit of speculation here. If it's possible that we can build a self-observing quantum computer, it will be as conscious as a self-observing human being. It'll also think about God and questions like that. Thinking, really, conscious being in a computer. Being, essentially, able to do what we can do, which is to make things snap one way or the other. But it's the possibilities, which all these different possible positions can add up, because what you have in quantum physics is something called superposition possibilities. If one switch is like this and the one next to it is like that, then the two add together, like making vectors. You have one like this, one like that, and you could add them all up and you get a whole bunch of different vectors going all different directions, and you get many, infinitely many different possibilities. Whereas with only this kind of computer, on, off, it's either this adds with this one, makes that one, or it goes down. You don't get any in-betweens, and therefore you don't get any states associated with any of the in-betweens. Whereas in quantum computers, you can actually get something associated with the in-betweens, provided you go look at what's going on in between. It's a very fascinating field. So it's one of the biggest fields in thinking today in quantum physics. Almost all the papers appearing right now are different aspects of quantum computation, because it affects everything.
We would like to again thank Dr. Fred Alan Wolf for explaining complex quantum physics concepts in a highly engaging manner and offering his insights on science, consciousness, and spirituality. Bright viewers, please join us next Monday on Science and Spirituality for the conclusion of our three-part interview with Dr. Wolf. For more details on Dr. Fred A. Wolf, please visit www.fredalanwolf.com. Books, CDs, and DVDs by Dr. Wolf are available at the same website. Thank you for your company today on our show. Coming up next is Words of Wisdom after noteworthy news here on Supreme Master Television. May the wonders of the universe forever inspire us all.
For more details, please visit www.suprememastertv.com/SS.